The universe is a vast, terrifying, yet beautifully predictable place. For billions of years, things have mostly worked exactly the way we expect them to. The sun rises, stars burn through their fuel, and the fundamental laws of physics remain completely unchanged. It feels safe. It feels solid. Gravity keeps our feet on the ground. Light obeys its cosmic speed limit, and the atoms making up your body hold tightly together. But what if this comforting reliability is nothing more than an elaborate illusion? A temporary cosmic trick played on us by reality itself. What if the very fabric of our universe is secretly unstable, resting on a precarious edge, just waiting for the slightest nudge to snap? This isn't the plot of a cheap sci-fi movie. It's a legitimate, terrifying concept in quantum physics known as vacuum decay. And if this theoretical event ever actually happens, it wouldn't just be an apocalypse. It would be the ultimate instant deletion of everything. It starts with a tiny bubble. Somewhere in the infinite vastness of space, a microscopic bubble of something called a true vacuum pops into existence. At first glance, it doesn't look like much. Just a subatomic speck of absolute, horrifying nothingness floating quietly in the dark void. But this tiny bubble refuses to sit still. It immediately begins expanding outward in all directions, hungrily consuming the space around it. And here is the worst part. It expands at the exact speed of light. There is absolutely no way to outrun it. This means if this bubble of doom was hurtling towards Earth right now, we would never, ever see it coming. The light that would warn us of our impending doom would arrive at the exact same millisecond as the destruction itself. One moment, you're sitting on your couch, watching an animated bird on YouTube. The very next moment, you, the Earth, the solar system, are simply erased from reality, leaving absolutely nothing behind. Just like that. Let's find out how the universe could end instantly. Welcome to the end of everything. Before we understand how the universe could instantly delete itself, we first need to talk about stability. In physics, absolutely everything is lazy. Every object, particle, and system in the universe actively wants to have as little energy as possible. Imagine a ball on top of a steep hill. It has a ton of potential energy, which makes it incredibly unstable and jittery. Given the slightest chance, that ball will roll down the hill, losing energy along the way until it finds a cozy valley. Once it settles at the bottom, it stops. It has reached its lowest possible energy state. Physicists call this being stable. Wood burns because its ashes have a lower energy state. Water flows downhill. Even you sinking into the couch is a low energy state. But this rule doesn't just apply to everyday objects. It governs the fundamental building blocks of reality itself, quantum fields. You see, the universe isn't just empty space filled with floating balls. It's actually a massive, invisible web of overlapping, vibrating fields. There is a field for gravity, a field for electromagnetism, and individual fields for every single subatomic particle that exists. Think of these fields as vast, cosmic oceans. And just like the ball on the hill, these oceans want to be as calm as possible. They want to shed all their excess energy and settle into their deepest, most relaxing cosmic valleys. When a quantum field finally reaches this absolute lowest energy state, it becomes perfectly still. We call this resting state a vacuum. In physics, a vacuum isn't just an empty box with nothing inside. It is simply a region of space where all the fields have zero energy. For billions of years, almost all the fields in our universe have been happily resting in their deepest valleys. They are perfectly stable. Well, almost all of them. There is one crucial, reality-defining field that might be hiding a very dark, universe-ending secret. Meet the Higgs field. Discovered in 2012, this invisible energy field permeates every single inch of the cosmos. To understand why it's so dangerous, we have to go back to the very beginning. Right after the Big Bang, the universe was a chaotic, ultra-hot soup. In this extreme heat, the Higgs field was completely turned off. This meant all the fundamental particles had zero mass, zooming around at the speed of light. But as the universe expanded and cooled down, a dramatic shift happened. The Higgs field settled into its valley and essentially turned on. Suddenly, the empty vacuum of space was no longer empty. It was filled with a thick, invisible cosmic syrup. Now, when particles tried to zoom around, they had to wade through this sticky Higgs field. It dragged on them, slowing them down. This resistance, this interaction with the Higgs field, is exactly what gives a particle its mass. Without it, everything would be weightless. Some particles, like photons of light, completely ignore the syrup and remain massless. But the particles that make up you, they get bogged down. And that is a very good thing. Because they slowed down, quarks and electrons could finally grab onto each other and form the very first atoms. The building blocks of matter were born, all thanks to the invisible drag of the Higgs field. From atoms came gas clouds, then stars, planets, chemistry, biology, and eventually you, watching this video on a screen made of mass. Without the Higgs field, there are no atoms. There is no matter. There is no stuff. Everything would just dissolve back into light-speed radiation. So, the Higgs field is basically the glue holding our entire reality together. We really need it to stay exactly the way it is. But remember the lazy ball on the hill? The Higgs field settled into its valley billions of years ago. It reached its vacuum state. At least, we think it did. What if the valley the Higgs field is resting in isn't actually the bottom? What if it's a false vacuum? Imagine you find our lazy red ball resting comfortably in a valley. You assume it's completely stable, at its absolute lowest energy state. But zooming out, you realize this valley is just a temporary ledge high up on a mountain. The real bottom is far, far below. So why hasn't it fallen already? Well, the ball is trapped in a small dip. There's a little speed bump, an energy barrier, holding it back. This state of being temporarily stable, but not at the true lowest energy level, is what physicists call a false vacuum. It's actually very common in nature. Take a piece of wood, for example. Sitting on a desk, it seems completely stable and happy to remain as wood forever. But wood isn't at its lowest energy state. It has a lot of chemical energy locked inside. It just needs a little spark to overcome its barrier. So, if the Higgs field is currently sitting in a false vacuum, what kind of cosmic spark would it take to push it over the edge? It would take an absolutely unimaginable amount of energy. The kind of energy generated only by the most violent events in the cosmos, like the collision of supermassive black holes or the fiery death of a hypergiant star. If a shock wave of energy that immense hit the Higgs field, it could potentially push the ball right over the bump. But here is the good news. According to classical physics, the barrier is simply too high. The universe has survived billions of years without it happening. So we are completely safe, right? We can just relax and forget about the giant abyss of doom? Well, no. Because classical physics doesn't rule the universe. Quantum mechanics does. Down at the subatomic level, things don't behave like normal balls on hills. Particles can cheat. They can bypass barriers entirely. In the quantum world, the Higgs field doesn't need energy to climb over the bump. It can just tunnel right through it. Welcome to a phenomenon called quantum tunneling. To understand how completely insane this is, imagine throwing a tennis ball at a solid brick wall. In the classical, normal world, the ball hits the wall and bounces off. Every single time. But in the quantum world, there is a tiny, incredibly rare mathematical chance that the ball just passes straight through the wall. This happens because subatomic particles aren't just solid dots. They are clouds of probability. Their location is a bit fuzzy. If the Higgs field decides to roll the quantum dice and wins, it doesn't need to climb the mountain. It just pops out on the other side. And once it's on the other side of that barrier, there is nothing left to hold it back. As it falls down towards the true bottom, it releases a catastrophic amount of potential energy. It becomes a runaway freight train of destruction. It plummets deeper and deeper into the energy well, until, finally, it hits the absolute lowest point possible, the true vacuum. And when it hits, it unleashes all that stored energy into a single, microscopic point in space. That massive release of energy creates a tiny sphere, the universe's very first bubble of true vacuum. Inside this tiny bubble, the Higgs field has reached its true lowest energy state. It is finally perfectly stable. Which is terrible news for us. Because it's at a lower energy state, it wants to share that stability with everything around it. It acts like a cosmic infection. The wall of the bubble pushes outward in all directions, turning normal, false vacuum space into true vacuum space. And it does this at the speed of light. But it's not just an empty void inside this bubble. It's a completely different universe. A universe where our laws of physics no longer apply. If this wall of true vacuum passes over Triduc, every single atom in your body and the planet would instantly fall apart. Inside the true vacuum, the Higgs field has a completely different value. This means the rules of physics are rewritten. Electrons might suddenly lose their mass entirely and fly away. Quarks might become 1,000,000 times heavier. Protons would rip themselves apart. The true vacuum might create entirely new particles and unknown forces, forming a bizarre universe that is utterly incompatible with human life. But why does it spread so quickly? Think of normal, stable space as a very long line of dominoes standing on their ends. The drop into the true vacuum is like pushing the first domino over. The energy released from that single drop physically kicks the space right next to it, knocking it over the edge too, which kicks the next piece and the next. It creates an unstoppable, self-sustaining chain reaction. Because of this massive energy release, the border of the bubble isn't just an invisible line. It is a thick shell of incandescent, ultra-hot energy. Any matter it touches doesn't just quietly fade away. It is brutally incinerated by the wall before falling into the void behind it. And as it eats more stars and planets, the wall absorbs their energy, growing hotter and denser as it ravages across the galaxy. So, an invisible, light-speed wall of incandescent death that deletes physics. Great. The natural question to ask now is, where is it? Has this true vacuum bubble already started somewhere out there in the dark? Our observable universe is almost incomprehensibly massive. It spans 93 billion light-years across, filled with trillions of galaxies. Given the sheer amount of space and time, it is entirely possible that a bubble of true vacuum has already popped into existence. It could have happened billions of years ago in a galaxy far, far away. And ever since that moment, it has been expanding outward, moving at the speed of light, silently making its way toward us right now. If a true vacuum bubble is heading for Earth right now, why haven't our telescopes seen it? Why don't we have early warning systems? To answer that, we have to understand the universe's ultimate speed limit. When you look up at the stars, you aren't seeing them as they are right now. You are seeing them as they were in the past. Light takes time to travel through space. Information takes time. For example, if our sun were to magically explode right this very second, we wouldn't know about it instantly. We would continue to see a normal, happy sun for 8 whole minutes, while the final light and the explosion traveled across space. Now, apply this to the true vacuum. The terrifying problem is that the bubble expands at the exact same speed as light. The light carrying the image of a peaceful, normal galaxy is traveling right alongside the wall of destruction that just ate it. This means the warning signal and the execution arrive at the exact same millisecond. There is absolutely zero warning. So, when you look up at the beautiful, peaceful night sky tonight, you are looking at a ghost. An illusion. Those stars might have been swallowed by the void millions of years ago, and we are just waiting for the darkness to finally reach us. If you're feeling a deep sense of existential dread right now, Congratulations, you're paying attention. But before you start building a bunker, which wouldn't work anyway, let's look at the actual math. Are we actually doomed? To figure out if the universe will delete itself, physicists have to carefully weigh two very specific subatomic particles. And when they plug those exact numbers into the equations, the final answer they get is going to be revealed right after we talk about today's fantastic sponsor, Brilliant.org. If learning about the impending deletion of reality makes you want to understand physics better, Brilliant is the perfect place to start. They have thousands of hands-on, interactive lessons in math, science, and computer science that make complex concepts actually make sense. To try it for free for 30 days and get 20% off an annual premium subscription, click the link in the description down below. Anyway, back to the end of reality. So, are we doomed? It all comes down to the math. The stability of our entire universe balances on the exact mass of two fundamental particles, the Higgs boson and the top quark. Physicists plotted the possible masses of these two particles on a graph to see where our universe falls. If we land in this large green zone, we are perfectly stable. If we land in this red zone, the universe should have destroyed itself instantly. But there is a third option, a razor-thin yellow strip right in the middle called metastable. This is the false vacuum, the ticking time bomb. For years, we didn't know the exact mass of the Higgs boson. But when the Large Hadron Collider finally measured it, we plotted the final coordinate, and it landed right here. Yes, based on our current understanding of physics, the universe is metastable. We are living in a false vacuum. This means that the decay of the universe isn't just a fun thought experiment. It is a mathematical certainty. It will happen. But remember how quantum tunneling is incredibly rare? To figure out when the universe will pop, we have to calculate the probability. And the probability is so insanely low that the expected lifespan of our false vacuum is something like 10 to the power of 100 years. That is so far in the future that all the stars will have burned out and the universe will be a cold, dead wasteland long before the bubble ever pops. But wait, earlier we mentioned that the universe is incredibly massive, and a true vacuum bubble could have formed billions of light years away. If it's been expanding at the speed of light since the dawn of time, isn't it eventually going to hit us? Even if it takes another billion years to arrive, it's still an unstoppable, light-speed wall of death heading our way, right? Fortunately, the universe has a built-in defense mechanism, a cosmic shield that protects us from distant threats. To understand it, we need to look at the fabric of space itself. Space isn't just an empty stage, it is constantly stretching. Ever since the Big Bang, the universe has been expanding in all directions, pushing distant galaxies further and further apart. And thanks to a mysterious force called dark energy, this expansion isn't just constant, it is actually accelerating. Imagine two bugs walking towards each other on a rubber band. If you stretch the rubber band, the bugs are pushed apart. If you stretch it fast enough, the rubber between them is growing faster than the bugs can crawl. They will never meet. This is exactly what is happening to the true vacuum bubble. The bubble is expanding outward at the speed of light. But if it started far enough away, the physical space between the bubble and Earth is expanding faster than the speed of light. Now, this doesn't break the rules of physics. Nothing can travel through space faster than light. But space itself doesn't have a speed limit. It can stretch as fast as it wants. It doesn't care about the rules. So, the terrifying bubble of doom is essentially running on a cosmic treadmill. It will keep expanding forever, destroying billions of galaxies, but it will literally never be able to reach us. So, we are completely safe from the rest of the universe. But what about ourselves? Could humans accidentally trigger the end of reality? Deep underground in Switzerland, scientists used the Large Hadron Collider to smash subatomic particles together at nearly the speed of light. These collisions pack an unimaginable amount of energy into an incredibly tiny, microscopic space. When the machine was first built, people were genuinely terrified. Could this concentrated blast of energy act as the spark that pushes the Higgs field over the edge? The answer is absolutely not. Not even close. You are vastly overestimating human capabilities. The energy required to punch a hole through the false vacuum barrier is hundreds of billions of times higher than anything our machines could ever produce. But more importantly, the universe has its own particle accelerators. They are called ultra-high energy cosmic rays. These are natural subatomic particles shot out of black holes and supernovas, and they hit Earth's atmosphere every single day. These natural projectiles hit each other with millions of times more energy than anything we can do in our tiny underground tubes. The universe has been conducting these high-energy crash tests on planets, stars, and moons for 13 billion years. Since the universe hasn't deleted itself from these natural supercollisions, we are 100% certain that humans aren't going to accidentally do it either. So we can't build a machine to destroy the universe, and the cosmic expansion protects us from bubbles far away. It seems we are totally fine, unless the bubble doesn't start far away. What if the quantum dice roll against us, right here, in our own galactic neighborhood? While the expansion of space pushes distant galaxies away from us, it doesn't work on things that are close by. Inside our local galactic neighborhood, gravity is the boss. It acts like a massive bungee cord, overpowering the expansion of space. So if a true vacuum bubble were to spawn inside the Milky Way, there is no cosmic treadmill to save us. The wall of destruction would rage across our galaxy, consuming star systems one by one, growing stronger and hotter as it approaches. Because it travels at the speed of light, it would hit the edge of our solar system completely unannounced. Down on Earth, it would be just another normal, peaceful night. You wouldn't see it coming. You wouldn't feel a thing. In a fraction of a millisecond, the wall of true vacuum would wash over the planet, instantly deleting you, me, and everything we have ever known. No pain, no panic, just gone. Replaced by a cold, alien universe where atoms can no longer exist. Wow, that is incredibly depressing. But here is the most important thing you need to remember before you close this video. Even if a bubble could spawn nearby, the probability of it happening in our lifetime, or even in the next billion years, is practically zero. You are infinitely more likely to be taken out by a giant asteroid, a supervolcano, or just slipping in your own shower. And in about 5 billion years, our sun will expand and swallow the Earth anyway. So the universe deleting itself is honestly at the bottom of our to-do list. Vacuum decay is a fascinating, terrifying quirk of quantum physics. It reminds us of how beautifully weird reality actually is. So don't lose any sleep over it. The universe might end in a single second, but until it does, enjoy the time you have. If you enjoyed this existential crisis, make sure to like and subscribe for more cheerful videos about the end of everything. If you want to celebrate your existential dread in style, we have brand new vacuum decay merch in our shop, including this stunning, highly detailed infographic poster of the particle phase diagram. Track exactly how close we are to the edge of reality on your bedroom wall. We also have the adorable, vibrating Higgs field plushie. It's so soft, you'll forget it's trapped in a false vacuum. And don't miss our new limited edition enamel pins, featuring the sweating Earth and the bubble of doom. Every purchase directly supports this channel and helps us spend thousands of hours animating existential dread. Link in the description. And of course, these videos are only possible thanks to the direct support of our amazing patrons. If you want to help us build a beautiful universe of educational content, consider joining them on patreon.org. Let the beautiful music play as the names scroll, honoring the supporters. A special shout out to our universe tier birds. You keep our reality stable.
You survived the existential dread. Now, please enjoy perfectly stable, beautifully boring space.
Out here in the quiet dark, even the death of a star is a gentle, beautiful waltz. A slow-motion supernova sheds its outer layers, seeding the empty void with the dust of creation. Somewhere, a rogue planet drifts without a sun, illuminated only by the faint, distant glow of the Milky Way. A world made entirely of crystallized carbon. A diamond planet reflecting the auroras of hidden magnetic fields. There is no rush here, no impending doom, just the slow, patient, perfect clockwork of orbital mechanics. Pulsars spin like cosmic lighthouses, sweeping beams of radiation across the empty void. Their rhythmic pulses are the universe's heartbeat, keeping time for 1 billion silent worlds. Massive gas giants harbor dozens of tiny moons, caught in a delicate, eternal gravitational dance. Beneath miles of cracked ice, warm oceans churn, hiding ancient secrets we may never uncover. Even when entire galaxies collide, it happens so slowly that the stars themselves almost never touch. They simply pass through each other like ghosts, weaving entirely new shapes in the dark. Asteroids tumble in the silent vacuum, ancient rocks holding the long-forgotten memories of the early solar system. Life, or the potential for it, slumbers quietly in the ice and dust, waiting for the exact right moment to bloom. Beneath it all, the quantum grid remains perfectly still, perfectly balanced, perfectly at rest. The universe is in no hurry to end. It has all the time in the world. Deep within cosmic clouds, gravity patiently gathers dust and gas, weaving them into the fiery hearts of brand new stars. When they finally ignite, they blow away the darkness, bringing light to entirely new solar systems. And even in the harshest, coldest vacuums, life finds a way to endure. The resilient tardigrade sleeps soundly among the stars.
Hello there.
Across the universe, there are oceans we will never sail, and sunsets we will never watch. Worlds of impossible colors dancing in the quiet dark. Galaxies grouped together like leaves on a cosmic branch, flowing endlessly along invisible rivers of gravity. And deep down, beneath the stars and the planets, the quantum fields hum in perfect harmony, supporting the atoms that make up the screen you're looking at, supporting the atoms that make up you. So, the next time you look up at the stars, try not to worry about the infinite void or a light-speed bubble of doom.
This is the life.
Instead, take
I'm
a deep
glad you're
breath.
here.
Appreciate the
Let's
utter
make this night
absurdity of
cozy.
existing at all. You are safe. The universe is beautiful. And the coffee is still warm. Sleep well. If you're still awake and hungry for more existential crises, check out our videos on black holes or the Fermi paradox. Links on screen. If you want to discuss the
Join
end
the
of the
vlog on
universe or just
Discord.
share bird
It's
memes,
awesome.
come join our massive
Join
Discord
us.
server. We'd love to have you. We also want to make science accessible to everyone. If you speak another language, you can help translate our videos and spread the dread globally. And don't
Subscribe
forget
to
to
our
sign up for our
newsletter for
newsletter
exclusive
so you
updates
never
and
miss a new
content.
release, even
Join
if
our
the algorithm
community
tries
today.
to hide us from you. A massive thank you to our incredible team who spent thousands of hours bringing this universe-ending scenario to life. From our researchers digging through dense quantum physics papers, to our illustrators drawing millions of tiny, beautiful stars, and our
Animation and
animators
motion graphics.
dedicating
Sample
their
1,
screens
sample
to
2,
bringing
sample
this
3,
terrifying
sample 4,
existential
sample 5,
dread
sample
to
6,
life
sample 7,
with
sample
perfect
8.
smoothness.
And
Huge thanks
original
to our
music and
audio
sound
wizards
design.
for crafting the
Jane
perfect
Doe,
original
John
score,
Smith,
keeping
Mary
your ears
Johnson,
happy
David
while your
Lee,
brain panics.
Sophia Ch-
And a
Narration.
special thank you to the
Scientific
brilliant
reviewers,
scientists and
Jane
expert
Doe,
reviewers who
John
made
Smith,
sure our quantum
Emily
math
Carter.
wasn't completely broken. As always, thank you so much for watching, learning, and supporting what we do. See you in the next one, assuming the true vacuum doesn't get us first.
Almost there. So close. Just a little further. Got it. Food. Ah! Z-z-z-z-D.